In this video, we will continue our discussion on general equilibrium, and with an example, I will explain about the Edgeworth box, how to construct the Edgeworth box, what is meant by Pareto efficiency, and what is a contract curve. Okay, so the difference between general equilibrium, what we call the Walrasian equilibrium also, and partial equilibrium, what we call the Marshallian equilibrium, I have explained that stuff in the earlier two videos. Okay, so I will not be able to explain all this stuff here. I will just try to show how to construct Edgeworth box, what is meant by Pareto efficiency. Okay, so this stuff I have explained it in earlier two videos. Okay, so in general equilibrium we have some basic assumptions, that is we have perfect competition in the sense that everyone is a price taker. There is pure exchange economy. Okay, no production is involved. We have two good model, person A and person B, and the goods are good 1 and good 2. Each person has some initial endowments. That means WA denotes the endowment of person A. That means WA1 here means units of good 1 that person A has initially, and WA2 denotes the units of good 2 person A has initially. Symmetrically, this is true for person B. Also, we have explained what is meant by allocation. Simply, every bundle in an economy is called an allocation. Okay, so XA, XB are the vectors of XA1, XA2. Okay, what does this mean? Simply, it shows the demand actually of good 1 by person A and demand of good 2 person A by person A. Okay, so these are the allocations, and we say an allocation is feasible if composite demand of good 1 by person A and B is equal to, you know, total endowment of good 1 by person A and B. Simply, when demand for good 1 by both person A and B is equal to the total endowment of good 1 that person A and person B has initially, we say the feasible, sorry, we say that allocation is feasible. Okay, now let us construct the Edgeworth box and explain this whole stuff. Okay, let's assume we have a person same. He has initial endowments, that is WA and WB. He has 60 units of apples and 60 units of mangoes. Bob is another person. He has 40 units of apples and 90 units of mangoes. Okay, so WA is equal to this stuff. Similarly, we can write here WA is 60 and 60. Okay, so WA is being denoted by these notations. I have taken this simple example. So these are the initial endowments of person A and B. Now let's try to construct the Edgeworth box. Okay, so I will try to be more simpler in explaining this step out. Okay, so wait for a second. I am trying to make it perfectly very simple here. Okay, so let us use another color here and another color here. Okay, this will be our Edgeworth box. Okay, so how do we construct the Edgeworth box in the first place? Since we have two persons, let us say this is the two the indifference curve of person A, and let us say this is the indifference curve of person B. I'm just trying to show you how did I make this Edgeworth box. Okay, so we have two persons A and B, let us say. Now to form the Edgeworth box, what we do, we just superimpose one indifference curve in two good space on each other. Okay, so if I combine these two, it is person A, let us say, and if I rotate this or superimpose it, so it will become something like this. Okay, then we get this Edgeworth box. Okay, so I was just trying to show you how did just we superimpose two indifference curves of two individuals on each other, and we form the Edgeworth box. Okay, Now let us construct the Edgeworth box. Okay, let us say we have two persons, Sam and Bob. Sam has 60 units of apples, 60 units of mangoes. This is the initial endowment of Sam. Bob has initially 40 units of apples and 90 units of mangoes. Okay, so this box shows us the Edgeworth box. Okay, let us say this is the origin of Sam. Okay, let me write it here, origin of Sam, and this is the origin of Bob. On this axis, on on these black lines, we measure the total endowment of mangoes. Okay, let us say how many units of mangoes we have. 60 plus 90, which comes out to be 150. Okay, if it is here 0, up to this it will be 150, because 90 plus 60 is 150. So we have 150 mangoes. Okay, let me write it here, mangoes on this axis and apples on this axis. Okay, so this black line shows us total endowment or total supply of mangoes, which is 150. And similarly, if it is 0 up to this, it will be obviously 150. Okay, it will be also 150, because it shows the units of mangoes. Okay, similarly, how many units of apples do we have in this economy? 60 plus 40 is 100, and we are denoting apples on this these green lines. So if it is 0 here up to this, the length of this will be 60 plus 40, which is 100. Okay, let me write it here. So it will be a 100 units of apples, and from this 0 to this point it will be 100 again. Okay, so they show 100 units of apples. This black line show 150 units of mangoes that we initially have. Okay, now let's draw the indifference curve for Sam first. Okay, let us say this is the indifference curve, something. Okay, let us say this is the indifference curve of Sam, and let us draw the indifference curve for Bob also. Let us draw it like this. Let us say this is the indifference curve of Bob. Okay, so this denotes the indifference curve of Bob. As I have explained, when we superimpose two indifference curves in two good space on each other, we form the Edgeworth box. Okay, length of this Edgeworth box is 150 mangoes, and width of this Edgeworth box is 100 apples. Okay, so let us say we are at this point where this green and red indifference curve intersect. Let us say this is a point W. Okay, if we are at this point, so let us say we have how many units of apples does Sam has initially. He has 60. Okay, so let me show it here. So this is 60 up to this. And how many units of mangoes does Sam has initially? 60. Okay, so let us say this is 60, this is also 60. Symmetrically, how many units of you know uh, apples does Bob has initially? 40. Okay, so let us go here and let us say it is here 40. Okay, so the width up to this is 40. And how many units of you know mangoes shown on this side does Bob initially have? He has 90. Okay, so let me draw it like this. Up to this it shows 90. Okay, now we are at a point W. Is there any way that we can move from point W to any of the point between this lens shaped curve, lens shaped figure, which is being formed by the two indifference curves? Before I will show it here, let us say we have a point X. Okay, if we move from point W to point X, you can easily see that Bob is on the same indifference curve, on the red indifference curve, but we can actually shift the indifference curve of same so that his utility increases. Okay, the basic definition of the indifference curve is simple. When we are at higher indifference curve, we are at higher utility. Okay, so moving from point W to X, same is indifferent. Okay, but the utility of, sorry, Bob is indifferent, but the utility of same will increase. This green curve will shift and it will touch at this point. Okay, so this is the Pareto improvement point. Okay, similarly, what about this point? Let us say this is Y. Here you can see if we move from W to Y, same is on the same indifference curve. Okay, so the utility of same does not change because he is still on this green line, but we can anyhow shift the red indifference curve here. Okay, drawing something like this. In this way we can increase the utility of Bob. Okay, that means sorry, the movement from W to Y is an Pareto improvement. Why? The definition of Pareto improvement is that if it is possible to increase the utility of one person without decreasing the utility of another person, we say the movement is Pareto improvement. So moving from W to Y, actually it is a Pareto improvement. Okay, and by the way, since we have formed a lens-shaped region by the indifference curves of two persons, this lens-shaped region shows that there is the scope of improvement. Okay, and let me show it here. Okay, so let us say this is our Edgeworth box initially, and we got two indifference such a way that they form a lens-shaped figure. If we are anyhow, okay, sorry, if we are able to you know vanish or diminish or get rid of this lens shaped figure, let us say by this, like this, then we say that we are reaching to a Pareto efficient point. By Pareto efficient we mean when the indifference curves of the two persons are tangent to each other. Okay, so this is what I want to show it here. Since we have the lens shaped region between the indifference curve of Sam and Bob, if we are able to, wipe out and this lens shaped figure to this, if it is possible, then we say when we reach at this point, we are actually at a point of Pareto efficiency. Okay, let me take it a point here. Let us say this is point Z. Okay, now if we move from point W to point Z, simple thing, if we move from point W to point Z, same is reaching to the higher indifference curve. Okay, let me show it here. So same is on the higher indifference curve. Similarly, for Bob, when we are at this point Z, okay, the movement from W to Z, we can also increase the utility, sorry, indifference curve or utility of Bob. Okay, so Bob's indifference curve will also shift like this. Okay, as I have told you, initially we have this lens shaped figure. Now we moved in such a way that we got rid of this lens shaped figure, such a way that the indifference curve of Sam and Bob are tangent to each other. When it is possible, you know, or when we are able to make the indifference curve of Sam and Bob in this example tangent to each other, the point where they are tangent is actually a Pareto efficient point. Okay, point Z is not just better for both Sam and Bob, it is also a Pareto efficient point. Okay, so let us see what are, if we are here, okay, corresponding to Z, let us show it here what is happening to the endowments. So 8 point Z, Sam is actually reducing his consumption of apples. Let us say it, if it was up to this it was 60, so let me write it here, it was here 60. Okay, so let us say he moves to 35. Okay, initially he was at 60, he has reduced his consumption of apples. And let us take this point here. So let me show it here. So it was here 60, and Sam has increased his consumption of mangoes, let us say 200. Okay, simple thing. Sam has exchanged apples for mangoes, and same is true for this. So let's take this coordinate. Here you can see Bob has increased the consumption of, on this axis we have apples. Let us say it is here 65. Okay, and corresponding to this you can see, let us say here it was 90 initially, let us say it has come down to 50. Okay, so we have moved to this figure. At this point you can see point Z is not just better for both, it is also a Pareto efficient, since there is no way to reallocate resources from that point without making one of the person worse off. Okay, that is on lower indifference curve. We have reached to this point Z in such a way. So what exactly does here we get? So let me rub this out. Sam has increased his, rather he has exchanged some apples for mangoes, and Bob has exchanged some mangoes for extra apples. Okay, so Sam goes from having 60 units of mangoes to 100 units of mangoes, and from 60 units of apples to 35 units of apples. Bob goes from having 90 units of apples to 50 units of apples, and from 40 units of apples to 65 units of apples. So what is the trade that gets Sam and Bob from point W to Z? Okay, you can see Sam trades 60 minus 35, which is 25. Sam trades 25 apples to Bob in exchange for, so from 60 to 100 we have moved to 100, for 40 extra units of mangoes. Okay, so this point is Pareto efficient. Why it is Pareto efficient? Because the marginal rate of substitution between Sam and Bob are equal at this point, where the two indifference curves are tangent to each other. So this was about how to construct the indifference, how to construct the Edgeworth box. So let me recapitulate it again. So we were having two persons, Sam and Bob. Sam has 60 units of apples and 60 units of mangoes. Bob has 40 units of apples and 90 units of mangoes. So on this axis, on this point, this is the origin of Sam, this is the origin of Bob. Okay, so total resources available of apples in this economy is 60 units of apples plus 40 units of apples, that is 100 units of apples. I have shown it on this green line, the units of apples that are in this economy, which is 100. If this green line is 100, this will be also equal to 100. So from point this O to point this, the length will be 100. Same is true for mangoes. So we have 60 plus 90, which is 150. So that this black line shows us the units of mangoes, this green line shows the units of apples. So number of apples in this economy is 150. So this is 150, this is also 150. Then what we did, we just draw two indifference curves in such a way that they intersect at point W. And let us say initially they were having say a 60 units, which is exactly true, 60 units of apples and 60 units of mangoes. Okay, same was having 60 units of apples and 60 units of mangoes initially. Bob was having 40 units of apples, okay, and 90 units of mangoes. Okay, so we were at this point W. Now we moved from point W to Z. I say the movement from point W to Z, rather this Z point will be Pareto efficient, because at this point Z, Sam will also increase his utility, his indifference curve will shift, and the indifference curve of Bob will also shift. Okay, so Sam's indifference curve has shifted to this direction, Bob's to this direction. At this point, the indifference curves are tangent to each other. We say when the two indifference curves are tangent to each other, the point is Pareto efficient. Corresponding to this, what was the final allocation of the resources of apples and Bob? It was simple. Sam got 100 units of mangoes and 35 units of apples, and Bob got uh, 50 units of apples. Okay, is it 50? Yes, 50 units of apples to 65 units of, sorry, 50 units of mangoes to 65 units of apples. Okay, so this is how do we construct the Edgeworth box. So let me show it here. What is then meant by the Pareto efficient point? Let me show it now simply. So if it was our Edgeworth box, Pareto efficient mean, let us say we have, these are the indifference curves of, let us say, person A. Let me show it here, person A and person B, and let us say this is the indifference curve of person A. When the indifference curves of two agents in an Edgeworth box are tangent to each other, and when we join these pointers where they are tangent to each other, we say we got a contract curve. Actually, contract curve is a locus of pointers where the indifference curves of two agents are tangent to each other. Okay, so contract curve is formed by joining all the pointers of the indifference curves. Sorry, my English is completely pathetic. Contract curve is actually a line which connects the points where the indifference curves of two agents are tangent to each other. This is meant by contract curve. And if we have two indifference curve in such a way, let us say first we have this indifference curve and then we have another indifference curve. If there is lens shaped figure, we say that there is scope for improvement. And if we are able to get rid of this lens shaped figure, let us say we got something like this. Okay, we shifted these two lines in such a way that they became tangent each other. So this point will show us Pareto efficient. Okay, I hope I make myself clear in this video. So I just try to make it more simple here. Now you may wonder, how did I got these two indifference curves or the preferences here? Okay, so it was just to show how do we, construct the Edgeworth box, what is meant by Pareto efficient point. Okay, I hope I make myself clear in this video. Thank you.